So hi, I'm Mark, this is Rebecca, Bryn, Conrad, Tim and Joe, and we've been doing periodic and aperiodic functions. So before we get into aperiodic and periodic functions, we ought to know what a function is first of all. And one of the best ways to think of a function is to think about it as a machine. Where we input something into the machine performs a calculation or process with this input and gives us an output. For example, in this function, we are multiplying everything by 2. So if we input 1, the function will multiply the 1 by 2 and give us 2. If we input 2, the function will multiply 2 by 2 to give us 4. If we input 6, the function will output 12. And if we input x, the function will give us twice the amount of x, so 2x. Normally we write functions in a very specific way, in the form of f of x. And for our last example, we'd have written it in the form f of x equals 2x. So the f part is just the name of the function. So this could be anything from h, I, j, Dave, whatever you want to call it. The x is the input, so what we're inputting into the function. And the blue bit after the equal sign represents the calculation, what we're doing to the input to get the output. So in this example, we're multiplying the input by 2, so we get 2x. It's also important that we know how to graph functions as well. So we put the input of the function along the x-axis, and the output of the function along the y-axis. So in our previous example, f of x equals 2x. Each of our y values is going to be double each of our x values because we're multiplying the input by 2 to get to the output. And for our other example, each of our y values will be 1 more than our x values because we're adding 1 to the input to get the output.
These periodic graphs, called the sinusoidal graphs, are composed of things used in trigonometry or triangle measurement, called sin, cos, and tan. They have many diverse uses, from modelling electricity, for example AC circuits, creating modern-day music, predicting sea levels, and even solving crime. Not all periodic functions have sin, cos, or tan in them. These are some examples, including the cycloid, the square, the sawtooth, and the triangle graph. The cycloid graph is created by mapping the position of a dot tangential to the circle as the circle rolls at a steady pace. The period will be every rotation, so equal to the circumference. The other three are usually created using synthetic man-made music through the use of subtractive synthesis, aka filters. To predict if a function, ft, is periodic, then we should be able to shift the function by a certain amount, constant, t, well, big T, to result in the same function. Therefore, for every given small t, ft should equal ft plus big T, where t is a real number. For example, big T can be represented on a basic sine graph as the distance between two peaks or two troughs or two middle parts or whatever. Because t, in this case being 360 degrees or 2 pi, is the distance before the function repeats itself. As mentioned in the previous slide, we need a constant period capital T in order for the function to be periodic. When this is the case, we call the function aperiodic, meaning no period. For example, the straight line on the left, called the linear graph, never repeats its x or y values, only repeats it once. And the curve on the right, called the quadratic, repeats itself, but not with a constant t.
Right, so what can we do with these periodic functions? So we can transform them and modify them in 4 particular ways. So we can change the amplitude, the period, the shift, and the intercept. Here, I'll show you how you can change the amplitude of the wave. As you see, the peaks and troughs are changing in their height from the axis. We can also change the period with the following example here. As you see, the wave gets squashed into the middle. And here we're changing the shift. So this is so right and left wave. And as the value of c changes, its position will change. And there's also a very particular case in this, where c is 90. And some of you may recognize this graph. This is actually a cosine graph. And then we can finally change the intercept. which is the height from the x-axis.
So as well as individual functions, we can also combine functions together. What this essentially means is we take our input, put that into the first function, take the output from the first function and put that into the second function. And so you can combine any two functions, but for this we're going to focus on three. Sin x, which is periodic, a half x plus 1, which is linear, and also aperiodic, and x squared, which is aperiodic but not linear, because it's not a straight line. As in maths, if a line isn't straight, it's not a line. Now, I got quite interested in trying to predict the results of what would happen when you combine two graphs together, especially if one of them is periodic and one of them is aperiodic. And I filled a few numbers, and eventually I came up with what I feel is rather an elegant proof, which will allow you to work this out. Unfortunately, as I'm sure many of you will be devastated to hear, we don't actually have time in this presentation for me to explain it to you. But it is on the poster if you want to see it afterwards. You can also show this visually, however. So if you take the two graphs, sin x and a half x plus 1, we can combine them in multiple ways. We can do sine of a half x plus 1, which produces this, and a half of sine x plus 1. Now both of these are linear, both of these are periodic, and this is because this graph is aperiodic but linear. If we take sine x and x squared, which is non-linear, and combine them, then we get these two graphs. This is sine of x squared, and this is sine of x squared. Now one of these is periodic, but the top graph there is not periodic, even though it does repeat, because as you can see the period here is quite wide, whereas the period here is quite small. So the period is not constant, therefore it is not periodic.
So as you may know, tides are periodic because they repeat over time. And this is because they depend on the position of the moon in relation to the sun and the earth. So for example, you've got spring tides, that they occur twice a month when the moon is in line with the sun and the earth, so that the gravitational pull of the sun and the moon on the earth reinforce each other to create the highest high tides and the lowest low tides. And on the other hand, you have neap tides, which occur twice a month as well when they make a right angle with the earth and the sun, and that's when there's the lowest difference between the high tides and low tides, because the gravitational pull of the moon and the sun almost cancel each other out because they're coming from two different directions, from there and from there.
Periodic and aperiodic functions should also be used to solve crime. To first understand this, you have to understand how electricity is transmitted throughout the UK. It's generated through a series of turbines which spin at a roughly constant speed of around 3,000 RPM, but which gives you this major sine wave. But due to supply and demand, you can have micro fluctuations which give you like an incorporated sine wave, which is aperiodic because it's very, very unlikely to ever repeat itself. As this is transmitted throughout the country, it can often be heard, like if you're out in the street, you might hear a hum, but if there's a recording taking place, a microphone will pick it up, and it can be used in court to determine whether an audio recording has been altered, and also when it took place, because the National Grid store in a big database the audio sine waves which occur from the audio generation.
And so, thank you for listening to our presentation. Yes, thank you for watching. And first, we'd like to do our own function here in this room. So if you could please, Mexican wave, starting from the front.